Hello, Honors Math 2. Let's see, this is Math 3, Module 1, Day 2. Yesterday we saw composite functions. To get ready for inverse functions, we need to talk about, first of all, what is a function and what is a one-to-one function. Should be kind of a breeze of a day. This should be a review for most of us from first semester already. So just kind of a recap of some terminology and some things before we start talking about inverses. Remember what a function is. A function is a relation, some relationship. Let's see, a relation is a function. A relation is a function if, you can complete my thought. A relation is a function if each input corresponds to only one output. A relationship is a function if each input corresponds to only one output. Okay, so remember a couple of things that we've seen very recently. Let's compare a function, something simple like y equals x squared. This is a function. The reason this is a function is for any input that we pick, let's say this input, that input corresponds to only one output. So it's a function. Something that we've seen recently that's not a function. Think of our conic sections. Very simple case of something that is not a function. You can think of many, but we'll keep it simple. X equals y squared. Our sideways parabola is not a function because I can find an input, this x value, that corresponds to more than one output. I can find an input, many of them, that correspond to more than one output. So that sideways parabola is not a function. And of course you say, Mrs. Anchuk, I also remember that we said this thing fails. What was that test? That thing fails the vertical line test. See if I can abbreviate. That thing fails the vertical line test. Many inputs have more than one output. Okay, we did talk briefly first semester about one-to-one functions, but maybe we need to reinforce that. Or did we call them one-to-one functions? Let's see. Basically, when a function will have an inverse. A function is a one-to-one function if any two different inputs in the domain correspond to specifically two different outputs in the range. That is, if I pick two different inputs, x1 and x2, are two different inputs, then the function is at one-to-one if the outputs are not the same. The outputs are different. Let's look at two functions once again. Okay, this thing is a function, but not, sometimes we say one-to-one, or we abbreviate that as one-to-one. I like that easy notation, one-to-one. So let me give you something that is a function, but not a one-to-one function. Our good old parabola up above. Yes, this is a function. This thing is not one-to-one because I can find an output going the other way that is mapped to more than one input. I can find an output that corresponds to two different inputs, so that function is not one-to-one. Okay, and I'm going to show you a function that is a one-to-one function. This is a nice one-to-one function, y equals x cubed. Y equals x cubed is a nice one-to-one function. Looks like this. For every single output, there is only one input. So that thing is a one-to-one function. This is a function, but not one-to-one. This is a one-to-one function. And we had a test for that. Notice that this function passes the horizontal line test. Or if I can abbreviate, the horizontal line test. Okay, so we have a test for something to be a function if it passes the vertical line test. In order for it to be a one-to-one function, it has to pass both the vertical line test to be a function and the horizontal line test to be a one-to-one function. That test means if you draw any horizontal line, it only passes that function at a single point. Alrighty, let's look at two relations. A relation is a function, or a function is a one-to-one function. So here's two relationships, figures 6 and 7, and the question is this thing a function? And then is it a one-to-one function? I'll pause so you can think about it. I'll say, is this thing a function first? And is this thing a one-to-one function? Is this relationship a function? Yes. Each input corresponds to only one output. Is this relationship a one-to-one function? And yes, this is a one-to-one function because going the other way, each output gets mapped to only one input. Okay, look at that next relationship. Is this thing a function, that relationship? And then is it a one-to-one function? Take a moment to think about those two. This relationship, yes, is a function because each input maps to only one output. The rabbit has a specific life expectancy. The lion has one specific life expectancy. So yes, it's a function. Now decide, is this a one-to-one function? I do want to say if it's not a function, you wouldn't even go any further. One-to-one implies it's a function. So if it's not a function, you would never be asked, is it one-to-one? Alrighty, so it is a function. Is it a one-to-one function? Pause and think about that. And you realize that no, this is not a one-to-one function since an output, specifically 10 and 11, there's two different ones that violate the one-to-one function. Since an output is mapped or corresponds to more than one input. Going the other way is not unique. The output of 10 is mapped to more than one input. So yes, it's a function, but not a one-to-one function. Okay, these next three visuals are just good for a little bit of practice if you want to look at that relationship, that mapping. Is that first thing a function? Is it a one-to-one function? Of course you can read. But yes, each input maps to only one output. Each output maps to only one input. So yes, it's a one-to-one function. Is that next thing a function? And is it one-to-one? Each input maps to one output, but there's an output that corresponds to two different inputs, so it's not a one-to-one function. Is this last thing a function? Does each input go to only one output? And actually no, that fails right away. I have an input that maps to two different outputs, so this thing is not even a function. Alright, thanks for looking. As we continue, just a couple more examples, and your homework today has a little review on if there's some composition of functions also, in case you breeze through this quickly. Now these are functions. Determine if this first function is a one-to-one function. So the question is this function one-to-one? Pause and think about that. Okay, thanks for looking. This is not a one-to-one function because I can find an output that corresponds to more than one input. Going the other way, it is not a one-to-one function. Please look at those ordered pairs. You're given that it's a function, but is it a one-to-one function? I'll pause so you can look. Is this function one-to-one? Okay, you should have said yes, this is a one-to-one function. My test is this, just to put it another way. It is a function, we knew it was, since no x values repeat. So I have 5 different x values. Okay, so I'm not mapping to the same y value, so I have x values that do not repeat. It's a one-to-one function since no y values repeat. Like if this had been a 5 and a 5, then you would have an output mapped to 2 different inputs. If that was a 5 and a 5, you would have one output mapped to 2 different inputs. But since none of those y values repeat, they're all unique. Each output is mapped to a unique input. So yes, it is a one-to-one function. All right, I think we're familiar with the horizontal line test. We'll go through it one more time, and these are too easy. I'll ask you these and then some other ones. The horizontal line test just says that if every horizontal line, that's what we said, intersects a graph at only one point, then the function is a one-to-one function. Please realize that this function is not one-to-one because it fails the horizontal line test. Okay, so the horizontal line test is to decide if a function is a one-to-one function. Please notice in this case, just to phrase it a different way, I have this value h. We have an output. And that output is h. That corresponds to 2 different inputs. 2 more than one input. So it's this mapping. I have an output that corresponds to 2 different inputs, x1 and x2. So that function is not a one-to-one function. These are too easy for you. I'll give you another case. Determine if f of x equals x squared is one-to-one. And determine if f of x equals x cubed is one-to-one. And then I want to ask you 2 more. Okay, that was too easy for you. X squared is not a one-to-one function. It fails the horizontal line test. But f of x equals x cubed, yes, is a one-to-one function because it passes the horizontal line test. Let's try something else. How about g of x is equal to the square root of x plus 2? Graph that and decide if it's a one-to-one function. This is a square root function shifted up 2, and that was a hook. So I go up 2, hook that function. Is that a one-to-one function? Does it pass the horizontal line test? Yes, it does. That is a one-to-one function. One more. Can you sketch h of x is equal to the absolute value of x plus 3 minus 4? Sketch that function and decide if it's a one-to-one function. Absolute value function is a V shape. I can find the vertex. This shifts my absolute value to the left 3, down 4. I get a vertex of 1, 2, 3, 1, 2, 3, 4, and that's a V shape. Please notice that that absolute value graph fails the horizontal line test. So no, it is not a one-to-one function. I should say not one-to-one. It is a function. It passes the vertical line test, but it's not a one-to-one function. Thanks for watching, and you'll try day 2 homework. Have a great day.